right, number 42, we are looking at commutes. So let's see, Jackie's commuting 30 kilometers to her job each day. She can drive at 10 kilometers an hour and it takes her 6 minutes less to get to work. She finds that she drives 10 kilometers faster. It takes her. So she can drive the slow speed or the fast speed, okay? So those are, and the distance is given to us, right? So her job it's 30 kilometers. That's the distance, right? And so we don't know what let's say our let statement, let X be the slow rate. So if that's the slow rate, the fast rate is 10 kilometers an hour faster. So we'll say X plus 10, I guess. All right, so here, and we know that if we go the fast rate, we will be 6 minutes less. I guess because this is kilometers and this is kilometers per hour, and then we're talking minutes. What is 6 minutes? Let's put this on the side over here. So 6 minutes, how many hours is that? That would be 1/10 of an hour, right? 1/10 of an hour. Okay, so let's establish that. So we know that distance over rate is the time that it would take. So we could say this is 30 over X for the slow rate. The fast rate, we can say it's X plus 10 over 30, or 30 over X plus 10. But we know that it's 1/10 of an hour less time. So if I write 30 over X, and then the time will be, that's the time for the slow one, right? So the fast speed, we're going to subtract 1/10 of an hour. That's 6 minutes, right? So let's go. Okay, so here we have the rate, which is whatever that slow speed is plus 10, right? So X plus 10 times, and the time would be whatever that slow time would be minus 1/10 of an hour, which is 6 minutes. So 30 over X minus 1/10 is equal to 30. So one of the things I could do is I could multiply by 10x here, or I could expand. I just like to expand first in this case. So we're going to multiply here, and then just distributive property happens twice, right? So I multiply X times 30 over X, and I undo that division, so I end up with 30. And then X times negative 1/10 is minus X over 10, right? Then multiply 10 by 30 over X, and I end up with 300 over X, right? And then minus 1, right, is equal to 30. And before I get too carried away here, you notice something right away. If I subtract 30 from both sides, it's going to be really nice because I'll end up with 0 here. So I'll have 0, right? And then what I need to do is multiply everything here by a lowest common multiple of the denominators. So that's the lowest common denominator. The LCD, if we only have 10 and X, there's nothing common there. So we're going to have to multiply everything by 10X. So let's do that. I'm going to multiply everything by 10X. So put 10X here. You know what? I'm going to erase this here because that's just kind of, it's a bit confusing, right? So multiply by 10X here and all the parts, right? Times by 10X here, and then also, well, that's 0, so it doesn't matter. When I do that, I end up undoing, let me change this to blue, okay? I'm undoing this division. So I've got minus X squared, And then I'm undoing this division here. Plus, now it's 3,000. And nothing cancels there, minus 10x. Okay, I don't like having a leading coefficient of negative. So if we multiply everything by -1, that will make things a little easier to deal with. So it would be x squared plus 10x, and then minus 3,000 is equal to 0. So when I go to factor this, let me change colors again. Let's see, let's go to purple. Okay, so I go to factor. I need to find a product that's negative 3,000 and a sum of 10. 3,000. What are some factor pairs? Well, 3 and 1,000 is not going to work. Something close together. Oh, 50 and 60. 50 and 60 will work, right? So plus 60, x plus 60, and then x minus 50, that will work, right? So we can't have a negative speed. So I'm going to cancel that one out. So let's change to another color, even again. We'll go with pink here. So x is equal to 50 kilometers per hour. And so the slow speed, what are we trying to find out? This is number 42. Her new speed is 50 kilometers per hour. The new speed, well, that's pretty easy. We just have to add 10, right? Is 60 kilometers per hour. All right.